Sometimes, when the night is too quiet and the room feels a little too still, I like to imagine I'm standing on the surface of Mars. Not the dry, frozen Mars we know now, but the one that might have existed long ago. I close my eyes and try to feel it on my skin, like a memory from a life I never lived. I imagine a sky that isn't just black and empty. Maybe it's hazy. Maybe it has clouds that drift lazily across a soft copper sun. I picture air thick enough that you could hear the wind as a low, gentle hum, not the thin, distant whisper we record today. I think of shallow lakes that shine like melted metal under the red light, small waves touching rocky shores that smell like iron and dust after rain. It's strange, isn't it, to imagine Mars with a scent, wet stone, rust, maybe a hint of something like cold, bitter tea in the air. You breathe in and your chest feels full, not because it's safe for human lungs, it probably wasn't, but because it's there, because the planet is wrapped in something warm enough to hold on to water, to clouds, to storms. A world that can keep its breath. And then I open my eyes and remember what Mars is now. Thin air, almost not there at all. So light that it would feel like wearing no blanket on a freezing night. The sky a faint salmon color in the day, but at its core empty. No soft protective pressure on your skin, just a near vacuum. A ghost of what might have been. So I sit in the quiet and I ask myself a simple question that feels like a wound. How did Mars lose its atmosphere? It's a dry question on the surface, a scientific one. You could answer it with numbers and models and equations, but when I think about it, it doesn't feel dry at all. It feels like asking, how does a world lose its voice? How does a planet go from maybe blue and maybe wet to silent and bare? I like to start very small. I picture a single grain of dust on Mars, billions of years ago. Just one tiny reddish grain resting near the edge of a small lake. The air is thicker. The sky is dim and pinkish, and that little grain is hugged by a pressure you can't see. The same way our own air presses on us, even if we don't feel it most of the time. If you were there, you might hear the soft slap of tiny waves against rock, the murmur of a breeze brushing past your ears. Maybe you'd feel the air push against your clothes, tugging gently. That little grain of dust doesn't know it, but above it, high above the clouds and the winds, the sky is already starting to change. The story of how Mars lost its atmosphere isn't a sudden catastrophe. It's more like a slow fading of color from an old photograph left in the sun. At first, you don't notice anything different, and then one day you realize the picture is pale and washed out, and you can't remember exactly when it started to fade. To understand why Mars faded, I think about its childhood. When the sun was young, it wasn't gentle. It spat out storms of charged particles, tiny, fast bits of matter from its surface in every direction. You can think of them like an invisible wind, but sharper, more violent. These particles rush through space at incredible speeds, like a constant storm made of things too small to see. Earth and Mars and all the other planets grew up in this storm. Now, Earth had something special. It had a strong magnetic field, a kind of invisible shield, shaped like a giant, stretched-out bubble around the planet. It comes from deep inside, from a core of liquid metal that moves and spins and creates a giant magnetic heartbeat. When the sun's storm hits this shield, most of the particles are pushed aside, forced to flow around us instead of straight into us. They crash into our upper air and create auroras, green and purple curtains of light that wave silently in our polar skies. Mars, in its early days, might have had something like that too. Not as strong, but enough to help. Enough to hold back some of the storm. Enough to keep its air hugged close. Enough to let water pool and stay, at least for a while. I imagine early Mars as a small, hopeful world. Smaller than Earth, lighter, a little more fragile. It forms from rock and metal, from collisions and dust and heat. Its insides are hot and messy, like a young heart beating too fast. Maybe it has volcanoes that roar and spill glowing rivers of lava, filling the air with gas, building up an atmosphere like exhaled breath. Carbon dioxide, water vapor, a mix of things that trap warmth and let liquid water exist on the surface. Not a paradise, but not a dead world either. And then, slowly, its heart begins to cool. A planet is like a cup of hot tea you leave on the table. At first, it's steaming, alive with heat, burning your tongue if you drink too fast. Then, minute by minute, it gives away that heat to the room. The steam fades. The warmth seeps out into the air. Eventually, the tea's just room temperature. No steam, no heat, just a memory of what it was a few minutes ago. Mars was smaller than Earth. Smaller means less heat to start with, and more surface area to lose that heat. It cools faster. Its inner metal core slows. The movement that once fed its magnetic shield weakens. What was once a heartbeat becomes a murmur, then a silence. The shield fades. And when the shield fades, the storm from the sun has a clear path. I imagine standing at the edge of a Martian lake at the moment the shield is truly gone. Of course, there wasn't one exact moment. It was gradual. But I imagine one, just for the feeling of it. The air around me is cold, but heavy enough that I can feel it in my lungs. There's a thin fog over the water, and the rocks are dark with moisture. The wind carries a smell like wet metal and cold dust, and when I touch the ground, it feels sticky with clay. If I could look up and see the invisible, I would see a wave of charged particles pouring toward the planet from the sun, like a river of electric dust. And this time there is nothing strong enough to push it away. The storm crashes directly into Mars's upper air. Each tiny particle, on its own, is almost nothing. But there are so many of them, arriving all the time, like sand grains in a storm of light. They slam into the highest layers of the atmosphere, knocking atoms loose, heating the thin air far above my head. Some of the lighter gases, the ones that are easiest to lift, begin to escape Mars entirely. They fly off into space, carried away by the energy of the storm like faint breath disappearing into cold night. This is one of the ways Mars began to lose its atmosphere, slowly, molecule by molecule, picked apart by the solar wind. There's a phrase scientists use, atmospheric escape. It sounds gentle, like something walking out a door. But what's actually happening is more like erosion, not of rock, but of air. The sunstorm acts like a constant, invisible sandblaster, stripping away the upper layers of the atmosphere over billions of years. I like to imagine the sound it would make if we could hear it. Maybe a thin, high hiss, like air leaking from a tire, or the faint crackle of static in a radio, but stretched out over ages, the kind of sound you'd only notice if it suddenly stopped. But the solar wind is only part of the story. Before the sun's storm could eat away at the top, something else had to happen too. Mars had to let go of its water. Water is heavy, in a way. It helps shape everything around it. It carves valleys, smooths rock, traps heat. On early Mars, water probably existed as lakes, maybe even small seas fed by rivers that cut dark lines across the landscape. We still see those scars today, dry riverbeds, channels, deltas frozen in time. They look like memories carved into stone. If you've ever walked by a dried-up river on Earth, maybe in a hot summer, you know the feeling. The cracked mud, the pale stones that used to sit underwater, the silence where there should be a sound of moving liquid. It feels like someone pressed pause on a living thing. Mars is like that, but for an entire planet. As Mars' atmosphere started to thin, it could no longer hold on to heat. The blanket got lighter, and the warmth slipped away into space. The air cooled. The pressure dropped. Imagine slowly taking air out of a room, pumping it away. Your ears pop, your voice sounds strange, you feel lighter but also more fragile. On Mars, this loss of air meant that liquid water on the surface began to boil or freeze more easily. Not because it was suddenly super hot, but because the lower pressure made it harder for water to stay in that gentle, flowing middle state. Some of it froze into ice, hiding in the soil, in polar caps, in shadows. Some of it turned into vapor and drifted upward to the thinning top of the atmosphere, where the sun's light could slice it apart. Sunlight, especially in its higher energy forms, can break water into hydrogen and oxygen. Hydrogen is very light. On a small planet with weak gravity and a thin atmosphere, those hydrogen atoms can simply leave, drifting off into space, gone forever. Every time that happened, Mars lost a little more of its water and a little more of the air that comes with it. Because water and atmosphere are tied together. Where there is one, the other can often follow. There's another quiet thief in this story, gravity itself. Mars's gravity is weaker than Earth's. If you stood on Mars, you'd feel about a third of your weight. Your steps would be softer. Your body would feel strangely light, like walking in a dream. Objects thrown into the air would hang a little longer before coming down. It sounds fun, almost playful, but for an atmosphere, weak gravity is a problem. The lighter gases like hydrogen and helium are always moving, always jostling. In a strong gravity field, most of them are held close, like restless children kept in a yard by a tall fence. But on Mars, that fence is lower. Some of the faster-moving molecules can jump over it. They reach the upper atmosphere, and if they're moving fast enough, they escape entirely, drifting away into the dark. Over immense stretches of time, this slow leak adds up. So Mars is being pulled in many directions at once, its inner heat fading, its shield weakening, its air stripped by the solar wind, its water broken and lost, its light gases slipping away into space. Each process gentle on a human timescale, but devastating over billions of years. Sometimes I think about this like a home that was once full of people. At first it's loud, it's overlapping, doors opening and closing, pots clattering in the kitchen, music from another room. And then one by one, the people move away. The last ones stay a bit longer, holding on, but eventually they leave too. The house doesn't collapse. It still stands, the walls are there, the floors, the windows, but the sound is gone. The air feels different. It's still a house, but it's empty, echoing, a shell. Mars is that house. Now we look at it and see dust and rock, thin air and cold plains. But if you listen carefully to the dry riverbeds, to the layered cliffs that once felt waves, to the minerals that only form in water, you can almost hear the echo of its earlier, thicker, wetter days. The thing that always gets me is how close Mars came. Not close to being another Earth, exactly, but close to being more. More active, more alive with chemistry, more hospitable to the strange experiments the universe likes to run with matter and energy and time. There might have been rain there, you know. Real rain. Imagine that for a moment. Droplets tapping on rocks that now sit under a naked sky. Little ripples spreading out in muddy puddles that have been dust for billions of years. Rain on Mars. The thought feels almost sacred. We sometimes talk about the habitable zone around a star, the range of distances where a planet could in theory have liquid water on its surface. Mars sits near the outer edge of that zone for our sun. Not too far, not too cold to ever have water, just close enough that with the right atmosphere, it could have lakes and maybe even shallow seas. So Mars did many things right, if you can call it that. It formed in a place where water could exist. It probably had a thicker atmosphere in its youth. It had volcanoes that fed that air and a magnetic shielded it for a time. It had energy, chemistry, and time. If you were writing a recipe for a world that might, just might, develop something interesting on its surface, some strange, tiny, fragile form of life, Mars would not be a bad candidate. But the universe is not sentimental. It does not promise anything. It only offers conditions, and then it waits. And on Mars, those conditions didn't last. As the planet cooled inside, its magnetic field faded. Without that, the sun's wind had a clear shot. It peeled away the outer layers of air. The pressure dropped. The surface water exposed to this new, thin, hostile sky could no longer stay liquid for long. It froze into the ground, or turned to vapor and rose, only to be sliced apart by sunlight and lost to space. Over time, the lakes shrank, the rivers slowed and then stopped. The air grew thin and dry. The planet's breath became so faint that it could no longer hold warmth. Winters bit deeper. Ice spread. Dust, freed from the grip of moisture, began to flow across the land in storms that still rage today, but in a world almost completely silent. Sometimes I imagine following a single molecule of carbon dioxide in Mars' atmosphere through this long story. At the beginning, it's part of a thick, heavy air blanket. It brushes against water droplets, bumps into other gas molecules, drifts over warm lakes and cool nights. It helps keep the planet's heat in, like a thin coat on a chilly morning. It might be pulled into a plant, if life ever existed there, or dissolved in a lake, or locked into a mineral. But maybe, instead, it drifts upward slowly over millions of years. It gets knocked higher by collisions, by heat, by chance. Finally, it reaches a place where the air is so thin it barely feels anything at all. There, the sun's energy hits it full force. It vibrates, it spins, it might even be broken apart. Maybe it survives, but gets caught in the rush of the solar wind, dragged away from the planet, stolen into the emptiness between worlds. One tiny piece of a great exhale that never comes back. At some point, enough of these tiny losses add up that the planet's surface feels different. The atmosphere is now less than 1% of Earth's. The pressure on the surface is so low that if you somehow stood there without a suit, the moisture on your tongue would start to boil, not from heat, but from lack of pressure. Your saliva turning to vapor, your blood struggling to keep gases dissolved. The air would be so thin you wouldn't hear much of anything. Your own breath would sound distant, your voice weak, as if the world were swallowing your words before they could travel. Mars lost its atmosphere, but it didn't happen in one blow. It was the result of many small weaknesses, its small size, its quick cooling, its fading shield, its vulnerable air, its closeness to a restless star. If you could speed up time and watch it from above, it would look like a planet slowly exhaling and never inhaling again. There's a mission we sent to Mars called Maven. Its whole purpose is to study how Mars lost its air. I like that we named it that, Maven. It sounds like someone wise, someone who's seen many things. Up there, circling the planet, it measures the flow of particles leaving Mars, the way the solar wind shapes what little atmosphere remains. It watches the slow, ongoing escape, the tail end of a process that has been going on for most of the planet's history. Imagine being that spacecraft, gliding silently through the thin edge of Mars's air, feeling the faint brush of atoms against your metal skin, listening to the soft hiss of charged particles streaming past. Below you, a world of canyons and volcanoes, dry riverbeds and frozen plains. Above you, a sun that looks small but still sends storms of invisible fire your way. When I think of Maven, I think of a doctor listening to the weak breath of an old patient. Not to save them, Mars doesn't need saving, but to understand. To learn how lungs work and fail, how air comes and goes, how life-friendly conditions bloom and fade on planets. Because the real question behind how did Mars lose its atmosphere is this: how fragile is a habitable world? We live on one that feels very solid. Our sky feels permanent. We wake up each day and the air is just there. Thick enough to carry the smell of coffee in the morning, the scent of wet asphalt after rain, the sound of cars and birds and distant voices. We rarely think about the invisible ocean of gas pressing on us from all directions, holding in warmth, protecting us from some of the sun's rage. But our atmosphere is not a given. It's the result of a long, delicate balance between our planet's size, its inner heat, its magnetic heart, its distance from the sun, the chemistry of its rocks, the slow explosions of its volcanoes, the life that breathes in and out on its surface. Change one piece enough, and the whole thing shifts. Mars is not just a dead world. It's a mirror, a quiet warning. A faded photograph of what happens when that balance tips the other way. Sometimes I imagine a version of us that evolved there instead of here. Fragile beings under a soft, early Martian sky, watching small waves on narrow lakes, wondering about the red glow of their own dusty sunsets. Maybe they looked up and saw Earth as a bright star and wondered if anyone lived there. Maybe they never existed at all. Maybe Mars' window for life was too brief, its air too quick to vanish, its water too fast to hide or flee. But the thought lingers. If conditions had held just a little longer, if the core had stayed molten, if the magnetic field had stayed strong, if the solar wind had been a bit kinder, would Mars have told a different story? When I let that question sit in my chest, it makes me feel a strange mix of sadness and gratitude. Sadness for a world that almost was something more. Gratitude that somehow on this neighboring planet, instead of that one, the balance held long enough for oceans to stay, for air to thicken, for forests and cities and people to rise. We talk a lot about going to Mars now, about walking there, building there, maybe even living there. I think that's beautiful in a way, to bring our own breath to a world that lost its own. To carry air and water and fragile human warmth to a planet that has spent billions of years in cold silence. But I also think we need to listen to what Mars is already telling us without words. It's telling us that planets are not eternal sanctuaries. They are experiments, balancing acts, constantly shaped by the fires inside and the storms outside. It's telling us that a sky full of air is not guaranteed. It can be stolen, slowly and quietly, by a star that doesn't mean to harm, but simply exists, burning, throwing out wind and light. It's telling us that habitability, that soft, comfortable state where water can flow and chemistry can dance and life can try things, is a temporary gift. When I picture Mars today, I don't just see a red desert. I see a place where time is written clearly on the land. The giant volcanoes that no longer erupt. The canyon so deep it would make Earth's grandest gorge look like a crack in the pavement. The dry deltas that once welcomed flowing water like open hands. The polar caps of ice, bright and still, holding the last big pieces of the water and air that once roamed freely. If you could stand there in a good suit and take a slow breath through your helmet, you'd smell your own recycled air, a hint of plastic and metal, and maybe your own sweat. Outside, the world would smell like almost nothing. Dry, sterile dust, faint traces of iron, no plants, no soil, no rain-soaked leaves. Just the cold, clean emptiness of a world that has let go of most of its volatile things. The wind would push dust against your suit with a sound like soft sandpaper. The sky would be a pale, washed-out orange in the day, darkening to a deep, almost black blue at night, with stars so sharp they'd feel like needles in the dark. The sun would be smaller, but still bright enough to make you squint. You could reach down and scoop up a handful of soil. It would feel dry, powdery, like flour mixed with fine sand. If you could somehow bring it close to your nose, inside your helmet, it might smell faintly metallic, like old coins or rusty tools. That dust has sat there, unwashed by rain, untouched by flowing water, for millions, sometimes billions of years. You'd be standing in the echo of an atmosphere. And maybe, just maybe, you'd feel a kind of quiet respect for this world that tried in its own way to hold on as long as it could. The universe is full of planets. We're finding them now, one by one, around distant stars. Some are bigger than Jupiter, some smaller than Mars. Some are too hot, some too cold. A few sit in that gentle band of distance where liquid water might exist. When we look at them, we wonder, do they have air? Do they have oceans? Do they have clouds, storms, maybe even something that looks back at its sky and asks the same questions we do? But then I remember Mars right next door, and I realize something. Being in the right place is only the beginning. Staying habitable is a long, delicate dance, and not every world can keep balance. Earth has, so far. Its core still spins, its shield still hums, its air still presses on our skin with a comforting weight. We hear thunder, we smell rain, we taste salt in the sea breeze, we feel warmth on our faces on a spring afternoon. All of that depends on an atmosphere that hasn't been stripped away, on a magnetic field that hasn't gone silent, on a sun that is, for now, stable enough. Mars reminds us that this balance can shift, that what feels permanent might not be. That a planet can go from maybe blue to forever red, from wet to dry, from thick air to thin whisper, without any intention, without any malice, just through the slow unfolding of physics and time. When I lie awake at night and think about all this, I don't feel scared. I feel a kind of soft awe. We are here now, in this thin window where our world is gentle enough to cradle us. We breathe without thinking. We talk and laugh and argue under a sky that has just the right thickness to scatter blue light and paint our sunsets in gold and crimson. Somewhere out there, other worlds are losing their air or gaining it or sitting in silence with none at all. Some are like Mars, once wet and now dry. Some are like Venus, thick with crushing, toxic clouds. Some might be more stable than Earth, more forgiving, their skies steady over eons. We don't know yet. But we will. And when we study Mars, when we ask how it lost its atmosphere, we're really asking, how rare is this thing we have? How long can it last? What does it take for a planet to stay kind, to stay breathable, to stay blue? Mars doesn't answer with words. It answers with dried riverbeds and stripped air, with frozen caps and dust storms. It answers with a silence that says, nothing is guaranteed. Worlds change, skies thin, lakes vanish, time moves. We, tiny and temporary, are lucky enough to stand on a world that hasn't yet lost its breath. So in this quiet room with the night pressing softly at the window, I imagine that early Mars again. The hazy sky, the faint sound of waves on a rocky shore, the cool, iron smell of wet stone under a dim sun. I let myself feel, just for a moment, what it might have been like for a world to inhale. And then I follow it through its long exhale, through the fading of its shield, the slow stripping of its air, the freezing of its water, until I'm standing on the Mars we know now, cold, dry, and thin-skied, under a vast, indifferent cosmos. Somewhere between those two visions, between the breathing Mars and the breathless one, I find a quiet lesson about existence. Everything that can change will. Planets, stars, galaxies, even the fabric of space and time. A thick atmosphere can become a whisper. A warm sea can become a plain of cracked stone. A living world can become a fossil. But in that constant change, there are moments, brief on cosmic scales, impossibly rich on human ones, where conditions line up just right for something as delicate, as improbable, as us. We are, in a way, the universe noticing that Mars lost its atmosphere. The atoms that once drifted in ancient stars, that might have passed near places like early Mars, are now arranged into brains that wonder, eyes that look, voices that ask. And maybe that's the strangest part of all. A small breathing creature on a blue world, sitting in the dark, imagining the lost air of a red one, and feeling in that distant loss a deeper appreciation for the invisible blanket wrapped around their own fragile home. Mars exhaled and never inhaled again. We are still in the middle of our own breath. And as long as we are, as long as we can smell rain and taste the air and feel the soft weight of our sky on our skin, we have the chance to look up, to look out, to listen to the quiet stories written in dust and light, and to remember that in a universe where even planets can lose their voices, our ability to ask why is in itself a kind of answer.